What are these blue crystals? They look like something straight from Arrakis, and I grew them myself using pool chemistry. The question is, how could one turn glassy crystals into a metal? This mineral is called chalcanthite, which means copper bloom in ancient Greek. And from chemical point of view, it's copper sulfate pentahydrate. And just like azurite, or better known malachite, it forms by weathering of copper ore, mostly represented by chalcopyrite. But how could be copper extracted? There are actually two ways to do it. The first one is pyrometallurgy, where heat is applied. It's a traditional method known to mankind for over 5,300 years, so nothing new. The second one is electrolysis, a relatively modern method where current is applied to a copper solution. And how much copper is hidden in crystals? Well, 25%. So in crystal of this size is this amount of copper. That's why I bought a lot of it, actually 4 kilos, approximately 8 pounds. I also have some copper nitrate left over from silver purification process I did in one of my previous videos called Silver Dyes. I boiled off all the water and I ended up with more blue crystals. And if you leave them overnight, they get wet, because the substance is strongly hygroscopic. I did a little flame test. See the green color? That's an indication of copper present. And here we have metallic copper. I did the first batch together with charcoal as a reducing agent that liberates copper from oxygen. But it's better to add charcoal later on, otherwise you risk that some sulfur will be trapped within the copper. And now it's finally time to smelt it. I'm using my rusty trusty foundry. Not gonna lie you, it smells like hell in here. Sulfur is in the air. There's a significant change in volume, so I need to charge the ore many times. There is definitely some liquid present. I removed slag and poured it into sand mold. I did recast the ingot, because I probably got an admixture of copper metal and sulfide. The yield is only 80%, but I think that a part of the copper is trapped within slag. The surface is porous, but it's actually compact. Let's deal with the rest. This time I will add carbon at the end to avoid any sulfur dissolution in metal. I added slag from the previous melt, as well as some lime, borax and charcoal on the top. This time I had no problem. The ingot looks fine and the yield is 111%. Well, that's because I extracted copper from slag from the previous melt. And now the second method, which is electrolysis. But before I start, there's actually another way. And all you have to do is immerse an iron object in a copper sulfate solution. As you can see, it's an instant reaction, where copper changes its position in the solution with iron. The layer is thin, but what happens if you let it sit in the solution longer? Well, no surprise, the layer gets thicker. I made a copper foil that way. And finally, electrolysis. I'm using carbon rods. And once the current is flowing, you get oxygen at one electrode and copper crystals at the other. If we let it run for a while, we get ourselves some nice looking copper crystals. Time to scale it up. I'm using a copper electrode for collecting copper and a steel one as a sacrificial electrode. And after 1.5 hours, all the copper precipitated from the solution, exchanging its position with iron from the electrode. Part of the electrode completely disappeared. I drained the solution and this is all the copper left behind. Now it's time to smelt it. By the way, look how the slag is still liquid. With this method, I achieved a 97% metal recovery, which is fantastic. The time has come to turn the copper into bronze. I did my research and it appears that the bronze edge swords had between 7 to 13% of tin. So for my amount of copper, I need approximately this amount of tin. But before I do the casting, I need obviously the model first. So I printed one of the available Crysknife models. I wasn't really happy with the shape of the blade, so I made a little adjustments. I selected sand casting as the way to go, it would be better to use a ceramic shell, but I currently don't own the technology. In other words, ceramic slurry is expensive. So I prepared the sand mold. There are some issues along the edges, but the rest is fine. This is the very moment I turned copper into bronze, by adding the tin into the molten metal. This is my first vertical pour, and what can I say? I underestimated the mold construction and overestimated the size of vent channels. I reinforced the seam of the mold by adding a strong clamp, and the result is way better this time. At this point, I need to clean the casting. A bit of grinding and it starts to look like a knife. But there is a lot of sanding in front of me. The sanding is done, and now it's time to polish it. The casting is not perfect, there are some flaws, namely porosity, but not bad for the first try casting bronze. And that's it. And if you are curious how I grew the crystals, well, the copper sulfate pentahydrate is used as a common pool chemistry. And there are many suppliers, many brands selling the same stuff. All you have to do is prepare an oversaturated solution. But be careful. Large copper intake leads to Wilson's disease, an illness so rare that it was in 2 House episodes.
This is Dr. Gregory House. Nice to meet you.
Dr. Hadley made a joke yesterday.
Which is funny, because you know Wilson's disease.
Fascinated by them.
Anyway, you can grow nice looking crystals. That's it. Thank you for watching, and as always, till next time.